We're going to continue on with the 4.1 lesson and the next objective of the idea of what we call the linear, because we're talking about relationships, the linear correlation coefficient. I love the name of that. Real complex, but it really isn't that complex. Coefficient, or the Pearson product moment correlation coefficient, is a measure. It's going to measure, this value is going to measure the strength and direction of our relationship. So when we have a hypothesis about how values are related, we want to know how strong they're related. What is the strength of this relationship or association? And that's what we call the correlation coefficient. It tells us a story about how strongly those variables are related to or correlated to each other. We use the Greek letter rho. We don't, probably not going to say it very often. The Greek letter rho, which is right there, represents the linear correlation coefficient. And R represents, let me fix that real quick. I have these backwards real fast. Not the correlation coefficient, the Greek letter rho, which looks like this here. It's kind of a weird shape P, represents the population correlation coefficient, and the letter R represents the sample correlation coefficient. Let me show you what that looks like from the PowerPoint. There it is. There's your Greek letter rho. And then your R represents the sample. We're going to, again, mostly deal with samples. And so we want to keep that. Now, to calculate the value, some classes do this by hand. You should know my class by now, that here is the value done by hand, and you have all these variables to plug in. What we're going to do in this class, of course, is use stat crunch to calculate this. We need to understand what the value means. What is the correlation coefficient? You should say that a couple of times, correlation coefficient, because you're going to use that language in this class. And so what's going to happen is when we measure the correlation coefficient, right, it's given a value, the correlation coefficient, or the R value. It's given some number, and that number, after it's calculated, has some characteristics. What we know for sure, the ones that you need to, there's a long list that I'm not going to read to you, but I think the important ones, you're going to take time to read that, is R. The value R is always a value between -1 and 1. So that's how we measure it. If it equals +1, there's a perfect linear relationship. So look at that. That's a perfect line. The R value equals 1. And then here, it's almost perfect. R equals 0.9. Not as perfect, 0.4. And then here it's going down. This is a negative. It's perfectly negative, so it's -1. And then you have other R values. This would be a negative R, negative. But again, R is measuring the strength of the relationship. And so you can read these here. And another important one is if R is close to 0, then there's little or no evidence of a linear relationship between the variables. Something like this. It's all just all over the place. So we're going to use that R as a measure of how strong the relationship is. And here are some examples of the R value and what the graph looks like for that. And so we're going to go ahead and compute it for the first time. So here's that same data. How strong is that relationship? So if you remember correctly, that graph looked like this here. And it looks pretty strong. I mean, it's a straight line going up. It looks like a positive value, but how strong is that relationship? So what we do to do that, we're going to use StatCrunch, and I think I have the examples here somewhere. Oh, I showed that to you before, but here is how we're going to do it. We're going to find the value for that. So let's go ahead and do that. We're going to get that in StatCrunch again. Here it is. Here's the graph. And so in this time, we're going to, instead of doing the graph of a scatter plot, we're going to do what's called a regression. So it's stat, regression, simple linear regression. Simple linear, straight line. And then you put your variables in again. Club head for X, distance is your Y. And then we go ahead and just compute. And notice when we do that, you get this output. It looks really complex. Get all of this information. You arrow over, there's your graph. There's kind of the fitted line. It's called, if you remember, the line of best fit, if you remember that from an algebra class. And it looks pretty strong. And then what we're looking for is the value right there. This R value, right? This R value from StatCrunch. I'm gonna cut it out real quick. Take a look here. There it is. Let's cut this out. Capture. Here is the output. Got it. And let's paste that in real quick so we can analyze it. We're going to put it over here so you get this information here. There it is here. And so you can see when we get it, this information tells us a lot. Here, what it's telling us here with this R value equals to, R is equal to 0.93869, or approximately I would say 0.94. This is what we would say close to 1. So if it's close to 1, where was it? The closer R is to a positive 1, the stronger the evidence is of a positive association between the two variables. So we have pretty strong evidence, since it's close to 1, that there's a positive relationship between those two. There's some other information we'll read here. This is an equation and some other sample size, but again, this is the important value there.